27 billion parameters on a phone. 27 billion parameters are now running on an iPhone 17 Pro at 11 tokens per second. Last week's release of Bonsai 27B by Prism ML squeezed a massive QN-based architecture into just 3.9 gigabytes, allowing for local reasoning that previously required a server farm. It is a mathematical trick that turns the standard 54 gigabyte footprint of a model this size into something that fits in your phone's per-app memory budget. The architecture solves the weight problem, but the real engineering happens in the specific binary training, the 1.125-bit weight architecture. Prism ML's one-bit approach isn't a simple post-training squash where weights are rounded down after the fact. Instead, the model is trained with binary language weights across the entire network, including the embeddings and the attention projections. Each weight is restricted to one of two values, either -1 or +1, using group-wise scaling to preserve signal. To keep the math efficient, they use a hybrid attention backbone, where 75% of the layers use linear attention. This structural change avoids the memory collapse, typically seen when models are forced into the sub-4-bit regime. But this extreme compression comes with a measurable cost to logic: the tool calling accuracy trap. The benchmark data reveals a 90% retention of intelligence compared to the full precision base model. In mathematical reasoning, Bonsai holds surprisingly firm, but the tool calling and agentic capabilities show a significant drop-off, sliding from an 80 score to a 66 in specific reasoning tests. It is effectively 4 times more sensitive to quantization errors in structured tasks than it is in pure text generation. However, achieving 27B-class reasoning at a true 1.125 bits per weight outperforms conventional 2-bit quants, which often collapse into gibberish. This trade-off suggests a new floor for intelligence density, where we prioritize parameter count over bit depth, the signal under the noise. This shift in intelligence density fundamentally redraws the boundary between local and cloud compute. By proving that 27 billion parameters can survive a 14:1 compression ratio, Bonsai 27B signals that the primary bottleneck for on-device AI is no longer memory capacity but memory bandwidth. The performance retention in math compared to the sharp decline in tool calling highlights that while raw logic can be binarized, the nuance required for external API interactions is still tied to weight precision. For builders, this means the choice is no longer between a tiny dumb model and a massive cloud model. It is between high-precision 7B models and high-parameter 27B binary models. We are moving toward a tiered deployment strategy, where reasoning happens at the edge and complex agency remains in the data center. Watch the adoption of custom 1-bit kernels in mainstream inference engines as the primary indicator for when these models move from research artifacts to production standards. Subscribe for more.